Okay, so now can you see my screen? Can you see my screen?
Yes, sir, we can see,
Okay,
but
okay, okay, okay,
yeah. Now the PPT is open.
okay. So hi and welcome everyone for land use and land cover classification with change detection using the time series analysis using the machine learning online training program. So basically this training I will take the class for 3 days online training program, and I will try to cover all of the machine learning method, all of the deep learning method which you want to need for making the land use and land cover classification using the Google Earth Engine platform. So I hope after completing the total 3 days online training program, you are able to do any machine learning method to develop your model for making the land use and land cover classification map. Okay, so let's go. Today is our first day, and the first day course content, basically today I will try to discuss about that land use and land cover, some basic information about this or just introduction part of land use and land cover. Then I also try to discuss about the remote sensing technique for land use and land cover classification. Then I also try to discuss about the land use and land cover processing using the remote sensing. And then what is the machine learning? In this time I will try to use here the machine learning. So that's why we need to use here the machine learning method. What is the machine learning, what type of machine learning, how it work the machine learning, all of the details I will try to discuss. And then machine learning methods, then machine learning classification, a lot of machine learning classification. We also try to discuss all of the things. So basically this class has the some theory part as well as some practical part. Okay, so basically this is the machine learning and deep learning method. So that's why first of all I need to discuss some machine learning method, then classification, then all of the argument I want to need discuss. Then I also try to show you the practical project work, so how we can easily make the machine learning method using the for the land use and land cover classification. So that's why in this time I also try to discuss some theory part. Then lastly I also try to show you the project work or practical work, so that you can easily understand all of the things. And then I also try to discuss about the supervised classification, then support vector machine classifier. So basically a lot of classifier will be available in Google Earth Engine platform, but first day I will only focus for the support vector machine. So I will talk all of the time using the support vector machine classifier, all of the details. And finally I also try to show you the live project or practical project using the support vector machine. Then I also try to discuss about the support vector classification argument, then what types of support vector machine, then popular kernels of support vector machine, different types of kernel for run the model of the support vector machine. We also try to discuss about the different types of popular kernels of support vector machine. And then we also try to discuss about the gamma. So mainly gamma is the function of the support vector machine. We also try to discuss about this. Then we also try to discuss about the cost function. And finally we will try to make the practical example of support vector machine using the Google land use and land cover classification map. Okay, and also try to make the practical example for identifying the deforestation using the support vector machine algorithm. So here you can see. So finally we also try to discuss our live project like this. So we also try to discuss about this project for, you can see, a practical example of LULC using the support vector machine, and we will try to identify the deforestation area. Okay, so in this time we also use at the support vector machine algorithm and try to find out the deforestation area, okay, using this support vector machine algorithm. So in we show the project work practically in the last part. Okay, so all of the theoretical part I completed first, then I will move to the practical example of the LULC using the support vector machine. And finally I also try to show you the another using another example for support vector machine. In this time I use here the Sentinel-2 satellite imagery, and also use here the European Space Agency. Mainly we can use the world cover 10-meter resolution data set. Okay, and you develop the model using the support vector machine and try to show you this. Okay, So let's go our step by step part and try to discuss about all of the details so that you can easily understand the practical work when I want to do in the practical example of LULC map using the support vector machine. You can easily understand. Okay. So let's go. Okay. So first of all, land use and land cover. So first, this is the two term, land use and land cover. This is the totally different. Okay. So first of all, land use or land cover. Land cover, it represent the physical condition of the earth surface. Okay, it's the totally physical or natural part of the earth surface. It can be forest, grassland, or river, or ocean. Okay, so this totally natural part. But when you want to move the land use, what is the land use? Land use is reflect the man-made activities, include use of land. So people are used for the land for the agriculture. People are used for land for making the industrial area. People are making the use the land for making the household or settlement. Okay, so all of the types activities are including the land use. Okay, and land cover is the totally natural condition, so physical condition of the environment. Okay, so mainly it can be forest, grassland, or other natural feature. But land use is the reflect by man made activities including the use of land. In this time here I use the land use and land cover, and it's indicated, and land use also indicated the employment of the land by human. Okay, so human use the land for their work for different types of activities, agricultural land, then industrial land, then for settlement land. Okay, a lot of use for land use. In this time I use the remote sensing technique for making the land use and land cover classification. Okay, I will use the remote sensing technique. So mainly remote sensing techniques are the most practical. First of all, it is the practical, then efficient cost efficient, and then provide the satellite data beyond by human vision. Okay, so mainly this is the most practical, and we can easily observe for the lot of area very quickly and efficiently. Using the remote sensing technique we can easily observe what is the condition of land use and land cover. We can easily observe. Okay, using the technique of remote sensing for land use and land cover classification, and it's the very cost is very efficient. Okay, so we can easily get the satellite image freely sources using the sentinel ones or landsat. We can easily get the satellite images, and we can easily identify what is the condition of the land for any place. Okay, so this is the cost efficient. And remote sensing provide the different types of data. It can be multispectral data or multi-temporal satellite data. Okay, we can use all of the image for accurate mapping. Okay, if you want you can use the multispectral data. If you want you can use the multi-temporal satellite image data for accurate mapping of remote sensing. Okay, okay, so what's the process when you want to make the land use and land cover classification map using the remote sensing? First of all, I will try to the basic process, then we also try to discuss about advanced process. Okay, so mainly when you want to use the land use and land cover classification map, first of all we need the satellite images. Okay, first of all you need to need the satellite images, and you can get the satellite image easily from any sources, suppose Earth Explorer or USGS. But in this time we don't need to use the Earth Explorer or USGS. We can easily get all of the satellite images from our Google Earth Engine dataset. Okay, so we already discussed about the Google Earth Engine dataset. So mainly Google Earth Engine dataset has stored lot of dataset. Okay, it can be Landsat, Sentinel, MODIS. Lot of dataset will be available in Google Earth Engine platform. We can easily use all of the dataset. We can easily use all of the satellite images and make the land use and land cover classification map. And you can see, suppose it should be corrected both radiometrically and geometrically. But when you use the Google Earth Engine platform, you don't need to radiometric or geometric correction because it's already done in Google Earth Engine platform dataset. Okay, so basically when you want to use the Earth Explorer or USGS website for downloading the data, then you also need to correct it by radiometrically or geometrically. But when you want to use the Google Earth Engine platform, you don't need to correction because this data is already corrected in Google Earth Engine platform. Okay, so that's why we don't need to any serious about the radiometrically or geometrically correction. This correction is already done in Google Earth Engine platform. So in this time we don't need to use the radiometrically and geometrically correction, because in this time we use here the Google Earth Engine platform. And after this we need to machine learning for develop this model. Okay, so when you want to get the satellite image, you radiometrically or geometrical correction is done, then you need to use at the machine learning model. You need to develop the machine learning model. So there are the lot of machine learning model. So in this time I will try to discuss about the what is the machine learning, what type of machine learning, and how I can relate it the machine learning with the Google Earth Engine platform for making the land use and land cover classification map. So first of all, what is the machine learning? So machine learning is a branch of artificial intelligence. Okay, so it is the branch of artificial intelligence and computer science which focus on the use of data and algorithm to imitate the way that humans learn. Okay, so in this time we learn the machine, so human can be learn the machine, and machine is also work according to the human interaction. Okay, so basically machine learning is the totally branch of artificial intelligence. Okay, so in this time the lot of machine learning method will be available here. Okay, so basically we can divide the machine learning method into the two way. We can easily divide. First method is that supervised machine learning. Second is that unsupervised machine learning. So in this online training program I will try to discuss about the supervised and supervised both things, so that you can easily use the two machine learning method for making your LULC map. Okay, so today basically I will try to more focus only for the supervised classification. Okay, only for the supervised machine learning method. And lastly I also try to some discuss about the unsupervised machine learning method. So basically supervised machine learning method is the popular method in this at this present time. Okay, so in this time you can see this is the classification of the machine learning method. So mainly we can divide the classification of machine learning in the two way. First of all, supervised and unsupervised. So when you want to use the supervised classification, it pre-categorized data. So supervised machine learning method is the pre-categorized data. Okay, so when you use the supervised machine learning, you already need the data. Okay, we can also say that this is the training data. So mainly when you use the supervised machine learning method, you must be need the training data or pre-categorized data. Okay, and when you use the unsupervised machine learning method, you don't need any training data. Okay, or you don't need any data for run the model. Okay, when you use the unsupervised machine learning model. But when you use the supervised machine learning model, you must be need the pre-training data or pre-categorized data. And we can easily use the supervised machine learning method. We can easily use for the classification. Okay, so in this time I will more focus only for the classification, not regression. Okay, I only focus the classification and classify the different types of feature on the earth surface using the supervised classification. Okay, so mainly we can use the classification for using the identify the different types of feature or identify the different types of feature on the land. Okay, and regression and this part is not here in this time, because in this time I only focus on the classification. So you can see mainly we can use the supervised machine learning for the two way. If you want you can use the classification, if you want you can also use the regression model. But in this time mainly we can use the regression model for prediction or forecasting anything. Okay, but in this time I will not go in the prediction or forecasting. So that's why I simply work with the classification only for this part, and all of the classifier I will discuss. Okay, so I will only focus on the classification so that I can easily identify the different feature on that surface. Okay, and also you can say unsupervised classification. Mainly we can use the unsupervised classification for using the clustering, then association, then dimensionality reduction. Okay, so but in this time for the clustering, so mainly when you want to use the unsupervised learning method or unsupervised machine learning method for making the land use and land cover classification, we mainly use here the clustering. Okay, we mainly use here the clustering model. Okay, so an association and the dimensionality reduction is not needed for the identify the feature. Okay, so basically when I use the unsupervised machine learning method, then I talk only for the clustering, not association or the dimension reduction. Okay, so today I mainly focus on the classification, and I will not finish the all of the classification today. I talk about only for the support vector machine classifier. Okay, and then and next day class I also try to discuss about the uh, random forest classifier, and also talk about the classification regression trees, all of the classifier I will try to discuss what is the background of this classifier, so that you can easily understand all of the details. Okay, and any question when you want to arise anytime, you can ask me. I also try to answer all of the question. Okay, okay, so let's go. In this time I try to discuss about the supervised classification model. So supervised is that the classifier package when you want to use the Google Earth Engine platform using the supervised classification for the traditional machine learning algorithm run in the Earth Engine platform. So mainly we can use here using the supervised classification model, using the classification and regression trees. If you want, you can use the forest, random forest, naive bias. We can also use here the support vector machine. Okay, all of the classifier we can easily use for run our model using the supervised classification. You can see all of the classifier we can use for supervised classification. Okay, not unsupervised. Okay, all of the classifier we can easily use for supervised classification model. So I will try to discuss all of the classifier, and I also try to show you the all of the practical example so that you can easily understand. So today I will try to show you the support vector machine classifier, all of the argument, all of the details, so that you can easily understand about the support vector machine. Okay, okay, so I hope you can understand, and when you face any confusion or any doubt, you can ask me any question, no problem. Okay, so if you have any question or any doubt, you can ask me. Anyone, any question or any confusion or anything, you can ask me. Any question? Any question, any doubt about this?
No, thank you.
Okay, okay, so you can ask me anytime when you face any confusion. You can ask me. I will try to answer all of the questions so that you can also easily understand. Okay, okay, so in this time, I will try to discuss about the general workflow of classification. So mainly when you want to work with the classification, we need to follow some follow step by step. Okay, so first of all, you need to the mainly this is the supervised classification, and when you want to work with the supervised classification, you must be need the get the training point. You must be need that get the training point. Okay, so first of all, you need to collect the training point. Okay, so when you want to work with the supervised classification, or then you need to collect the training point and assemble the feature which have a property that is stored the known as the class level and property. Okay, you need to select the class level. When you want to get the training point, you need to select the class level, as well as you also need to store the property name. A property storing in the numeric values for the predictors. Okay, so I also try to show you this part, how you can easily get the collect the training point and all of the things, how you can easily get the class level, and also store the property storing the numeric values. Okay, and then you need to the classifier set its the permanence if necessary. So when you want to work with the classification using the supervised machine learning, you must be set a classifier. This classifier can be random forest, this classifier can be support vector machine, this classifier can be classification and regression, any classifier you need to set, and then train the classifier using your training data. Which data you want to collect, you need to train this training data. Okay, so we can easily train the training data, and finally we can classify the image, and finally we can estimate the classification, and with independent validation data. For mainly we can use this for getting the accuracy assessment of this map. Okay, so in this time support vector machine, so we can say that all of the classifier, when you want to use the all of the classifier, we need to use at the different types of classifier. So support vector machine, this one of the best classifier. Okay, So in this time, I will try to discuss about the support vector machine. Then I also try to discuss about the how it will be work for the support vector machine. Okay, so mainly support vector machine is one of the most popular supervised learning algorithm, which is used for the classification as well as also regression problem. But in this time, I use only for the support vector machine for making the classification of on the earth surface different types of feature, not regression. Okay, so I hope you can easily understand all of the things. So in this time, support vector machine. So support vector machine we can use for mainly we can use for the regression and classification. Two types of work we can done using the support vector machine. But in this time, I will only focus on the classification problem. Okay, not regression. And this support vector machine has a goal. This goal is that it create a line. This line called the decision boundary. So support vector machine has a goal. This goal is that it create a decision boundary that can segregate an n-dimensional space into the class so that we can easily put the new data point in the correct category in the future. And this is the best boundary is called the hyperplane. Okay, so I will simply show you the figure that you can easily understand about it. So you can see example. Okay, so you can see this is the figure of support vector machine. So here you can see, suppose you can just remember that this is the point, this is the point, this is the point. Suppose you can say that this point, all of the point for the green color point, we can identify the green color point as a, suppose this is the pixel value of water. Okay, so this is the pixel value of water. We can suppose say that this is the pixel value of water, and also we can say this is the green color. Suppose we can say that this is the pixel value of build up area. Okay, so this is my one class for water, and this is the one another class for the build up area. And also we can see this is the nearest line. So this nearest line, you can see this nearest line. Okay, so this is the line, it's called the decision tree. Okay, so it's called the decision tree, decision boundary, sorry, this is called the decision boundary. And also you can see near the value of decision tree, you can see this is a lot of pixel value for the water, a lot of pixel value build up area, but which point or which value or which pixel value is near the decision boundary, it's called the support vectors. Okay, so you can see this point and this point, this pixel value and this pixel value is near to the decision boundary, so that's why it's called the support vectors. Okay, so this is a support vectors, this is a support vector, and it's called the, you can see we also divide the hyperline. Okay, so you can see in this time from this distance, this is my decision boundary, and from this pixel value, this is the minimum, this is the minimum distance from the decision boundary. You can see minimum distance. Okay, this is the minimum distance. Also from this another pixel value, you can see this is the minimum distance from the decision boundary. Okay, so when it will be balanced and created the minimum distance from the different two class, this is the water and this is the build up area, it will be created the two classes support vector. You can see this support vector from this point, it will be just showing that the minimum distance, also showing the minimum distance. So it created the optimum position of the decision boundary. So support vector machine is the main goal is that you can see the support vector machine goals algorithm is to create the baseline or decision boundary. It created the baseline or decision boundary that can segregate the n-dimensional space into the class so that we can easily put the new data point in the correct category in the future. Okay, and the base decision boundary is called the hyperplane. Okay, so in this time you can see this is the hyperplane. Okay, so we can divide it, this is the this hyperplane for the water, or this hyperplane for the this hyperplane line for the build up area. Okay, and also you can see it's called the maximum margin. Okay, it's called the maximum margin. Okay, So we all, when you want to work with the machine learning method, we also need to put all of the training point. We also need to put here the hyperline position, all of the things we all do need. Okay, so basically this is the basic figure. Okay, you can see here support vector machine can be also divided into the two type. So basically we can divide into the support vector machine the two type. First type is the linear support vector machine. So linear support vector machine is mainly is the linear separable data. Okay, linear separable data, which means if a data set can be classified into two class by using a single straight line. So in this time you can see this is the linear. Okay, so here I use the linear line and classified the two class. This is my one class and this is my another class. So this is my linear support vector machine. Okay, so you can see what is the definition is that linear support vector is the use for the linear separable data, which means if a data set can be classified into two classes by using a single straight line. In this time I use here the single straight line and classified the two data set or two data set. Okay, then such data is term is the linear separable data and classify is called the linear support vector classifier. Okay, and what is the another type is the non-linear. So mainly non-linear support vector machine is used for the non-linearable separate data. Okay, which data is not is the we cannot divide the line into the separately in the middle part or a straight line we cannot divide the two data set. This called data set is also called the non-linear support vector machine, and such data is the term is the non-linear data classifier used for the non-linear classification method. But in this time when I use the Google Earth Engine platform, I mainly focus on the linear support vector machine and try to classify our model. Okay, here you can see this is the another example for suppose you can see this is the pixel value for the water and this is the pixel value for the vegetation. Okay, in this time you can see this is my decision boundary and you can see it's and this is the minimum distance between this pixel value, so that's why it's called the support vector. Okay, and also you can see it's called the support vector because this is the minimum distance from my decision boundary. Okay, and in this time it created the optimal hyperline. Okay, it created the optimal hyperline and classified the two things, this is the water or this is the vegetation, and maximum margin you can see this is the maximum margin. Okay, so basically it's called the linear support vector machine. Linear support vector machine is that mainly this support vector machine algorithm help to find out the best line or decision boundary. This is the best boundary or region is called the hyperplane, and support vector algorithm finds the closest point of the lines from the classes. So it find the closest point of the lines from the both class. Okay, and this point are called the support vector. This point called the support vector, and the distance between the vectors and the hyperplane is the called the margin. Okay, so you can see what is the distance between the vector and the hyperplane. So you can see this is my vector support vector and this is the distance, this distance called the margin. Okay, so it's very important because when I want to put my algorithm then we also need to define the margin. So you can see what is the margin. Margin is the distance, margin is the distance between the support vector and this is the decision boundary. Between this distance we can say that this called the margin. Okay, and the goal of the support vector machine is the maximize the margin. Okay, so at the goal of the support vector is the maximize the margin, and the hyperplane with the maximum margin is called the optimal hyperplane, and you can see this is the optimal hyperplane. Okay, so basically in this time we use here the support vector machine and we also need to know some argument about the support vector machine. Okay, so there is the law, you can see this is the all of the argument. Okay, and we also need to know about the all of the argument types, all of the things. So basically when you want to work with the Google Earth Engine platform, we need to know about all of the argument. Okay, you can see this argument is the decision procedure. Also you can see support vector type, kernel type, shrinking, degree, gamma, cost. Okay, then nu function. Okay, we need to all of the argument when you want to run the support vector machine using the Google Earth Engine platform. Okay, so first of all you can see support vector classification algorithm. So here you can see decision procedure. So mainly decision procedure is that we can say that this is the use the classification. we can use the margin and voting. Okay, so you can see we already discussed about the margin. What is the margin? Margin is the distance between the decision boundary and support vector. This distance we call the margin. So when you want to input the decision procedure, if you want, you can use the voting or margin. So in this time, we use here the margin. Okay, so margin, what is the margin? Margin is the distance between the support vector, support vector from the decision boundary. Okay, and then also you can see support vector type. So there are the lot of support vector type: one linear, CSV, NUSVC, one class. Okay, NUSVR. Okay, we also try to discuss later of the support type when you want to work. And you can see different types of kernel type. Kernel, it can be one of linear. We can also use here the poly. Also you can use here the RBF. Also you can say, I also try to discuss about the equation like this. So I also try to discuss in this time in here. So in this time I also try to discuss about the popular kernels of support vector machine. So support vector machine has some popular kernel. It can be, you can see, polynomial kernel, Gaussian kernel, radial biases function, or short name is that RBF kernel, and Laplace RBF kernel, sigmoid kernel, ANOP RBF kernel, and lot of kernel will be available here. But in this time, I will discuss some kernel. Which kernel we want to need when you want to work with the Google Earth Engine platform. I also try to discuss about this. So in this time, you can see polynomial kernel. So basically, when you want to use the machine learning using the polynomial kernel is a kernel function commonly used with the support vector machine and other models that represent the similarity of vector training samples. Okay, so when you want to work with the lot of training sample, suppose you want to classify the lot of classes or lot of training sample you want to get. Okay, then you need to use here the polynomial kernel. Okay, and also you can see this is the most popular kernel. It's called the RBF, or we can say that this kernel is that radial basis function. Radial basis function is that we can say that mainly we can use the radial basis function is that you can see this is the kernel are the most generalized form of the kernelization and is one of the most widely used the kernel due to its similar to the Gaussian distribution. And when you want to work with any two class, suppose I want to need the classifier only for the vegetation and build up area, I need only for the two class. Okay, then you can also use the radial basis function. Suppose you can see when you in this example you can get the 2 point x1 and x2. You compute the similar for how close they are to each other, then we can use the equation. You can see this is the equation. So you can say that in this time this x1 is one of pixel value, suppose water, and this x2, this is the another pixel value for the suppose build up area. So I want to use this equation and I can easily make the model for the radial basis function only for the two classes. Suppose this is the water, this is the build up area, and I can simply use the equation. Okay, when I use the RBF or radial basis function, then it's automatically created. Okay, it's automatically created this function, and I can easily calculate the distance between the two classes. And here you can see the sigma is the variance and our hyperparameter. And also you can see this is the another thing is called the this is the modulus between this distance x1 minus x2. It is the Euclidean distance between the 2 points. Okay, so basically we can use the RBF or radial basis function, and we also try to make the land use and land cover classification map. Okay, so in this time you can see the gamma. So gamma, this is the another most popular argument for support vector machine. So here you can see we can get the gamma distribution the two type. We can say that one number of gamma is the high gamma and low gamma. And gamma, the next importance parameter is the gamma, and the gamma parameters defines how far the influence of a single training example. This means that high gamma will consider only points close to the hyperplane, and low gamma will consider the points at the greater distance. So here you can see it showing the some point. You can see this is the apple and this is the orange. Okay, so in this time I simply, this is my decision tree, also decision boundary. So this is the decision boundary, and here you can see all of the point will be distance. This distance is far. Okay, you can see this distance is the far than this. Okay, also you can see here the distance is the closer. All of the sample is the closer to the decision boundary. So when you can see this decision boundary, this sample is closer to the decision boundary, it's called the high gamma. Okay, when it, we can see some also you can see this is the some sample is the closer, but lot of all of the most all of the sample is the distance and the long distance between the decision tree. So that's why we can say that this is the low gamma. Okay, and this is the high gamma. What is the high gamma? High gamma is the low distance between the sample and decision boundary. And what is the low gamma? Low gamma is the long distance between the decision boundary with the samples. Okay, so I hope you can easily understand about the gamma. In this time, okay, so you can see in this time I will try to discuss about a function. This called the cost function. Okay, so basically this is the another argument of the support vector machine. It's called the cost function. We can use the function for, mainly we can use the function for train the support vector machine. By minimizing the value of theta, we can ensure that the support vector is accurate as possible. So when this theta, when this value of the theta is low or minimized, we can ensure that the support vector machine is accurate as possible. Okay, in the equation we can say that the function cost 1 and also cost 0, we can refer to the cost 4 and the example where y is the 1. And okay, so this is the basic information about this, but we don't need to anything because we can just put the theta value. Okay, theta value in our code. When I run the code, we can just put here the theta value. Okay, and we can easily run our model. So it's called the cost function. Okay, we can use the cost function. Mainly it's identify the minimized value of theta. We can ensure that the support vector machine is the accurate as possible. Okay, so basically this is our talk about the support vector machine. And in this time, if you have any question or any doubt about the support vector machine, you can ask me. Anyone any question or any doubt for the theoretical part? Any question or any doubt about the support vector machine? Then I also try to discuss about the next topic for practical example. So basically, I also after completing this session, I also try to send you a machine learning and deep learning book, so that when you can read this book, you can easily understand all of the term about the machine learning. And it's very difficult to learn the machine learning and deep learning. You also need to read some book, okay, for the basic or clear identify about all of the parameters. Okay, so and this is the vast topic. So in this time, if you have any question or any doubt, you can ask me about the support vector machine or different types of argument. Any question or any doubt? Anyone? You can see this is the radial bias function. Any question or any doubt?
No question for me.
Okay. Okay, so I also send you this the slide, so your practice, you can also read all of the things again. And I also send you all of the details. And after completing this 3 days online training session, I also refer you some book of the machine learning and deep learning. Then you can easily read all of the book. Then you can easily understand all of the things about the background of the machine learning. Okay, so let's go. In this time, I will focus on the practical session. So I simply work with this. So in this time, I want to make the land use and land cover classification using the support vector machine. And I also try to identify the deforestation region. Okay, forest region, and this I in this time I classified the two things. Okay, so I classified the deforestation as well as also forest region. Okay, so in this time, here you can see I also take the screenshot. So in this time, I simply use here the classifier. You can see support vector machine, and I can simply use for the 3 argument. and I already try to discuss all of the argument, but in this model, when I run this model, I can only use for the three argument. Kernel type, I can use here the radial bias function, and gamma, what is the gamma and the cost. So I already discussed all of the three argument, okay, kernel type, gamma, and cost. Okay, so now I simply open this code and try to discuss all of the things, so that I hope you can easily understand. And I also give you some homework using the classifier. So when you can do this, then you can easily understand all of the details. Okay. Okay. And after this, I also try to show you this model for the support vector machine model using the Sentinel World satellite imagery, and also use here the European this data set. Mainly this is the recently data set for world cover 10-meter resolution, how we can easily use, and also try to discuss about the accuracy assessment of this data. Okay, so let's go. So I simply open my new code editor. So just a minute, wait a minute.